Today's lesson is on dimensions, talking about spaces of different dimensions. Now, so a couple definitions. A point is a location in space, and space is the collection of all possible points. These definitions are circular. Each one requires knowing what the other one means to understand its meaning. Therefore, these are lousy definitions. What can we do about that? Well, lousy definitions are our only options at times. This is unfortunate. We have to just get to the point where you say, do you know what I mean? Can you imagine what I mean by space and locations in space? Good. Now, every location on a number line can be identified with a single number. So there's a number line and there's values on it. If I were to say, where is the number 2? Bang, there's the number 2. It's already labeled. If I say, where is the number 1.5? Right there. It's, one step and then one whole step and then a half step away from start, which is the same thing as 0. Now, a lot of people understand that 1.5 is halfway between 1 and 2. It's also half a step beyond 1. Now, a lot of people have a little bit of trouble with this. If I say, where is negative 1.5? It's there. It's not a half a step to the right of negative 1. It's halfway between negative 1 and negative 2. So that is 1.5. Excellent, excellent. Because every location on a number line can be identified with one single number, we say that a line is one-dimensional. Its points can be described by a single number. So, to talk about different places on a line, you only have to give a single number. On a highway, if you're on a highway and you break down, you call the police, they say, where are you? If you can find a mile marker, you say, oh, I'm on, highway 90, I'm at mile marker 247. Oh, now they know where you are. A single number is all that it takes. Now, every point on a plane can be described by a pair of numbers. Thus, we say that a plane is two-dimensional. The first number gives you the point on the x-axis. The second number gives you the point on the y-axis. X comes before y in the alphabet, that's why we do it. We have to have some sort of formulation. So, if you want the number 3, 1, you go 1, 2, 3 steps on the x-axis, 1 up on the y-axis, there you are. That's the point 3, 1. If you want the point 0, negative 2, you go 0 on the x-axis, that's you stay at start, and then you go negative 2 down. There's 0, negative 2. For some reason, points on the y-axis and the x-axis are the hardest ones for students, generally. Anyway, let's see. What's that point? Well, we do the x-coordinate first, 1 step back, negative 1, and then 2 steps up. That is negative 1, 2. What is that point? That's 2 steps back and 1 step down. That's negative 2, negative 1. We always give the x value first and then the y value. One last point, that point over there, it's 4 positive. Well, actually, it looks a little bit less than that. When I give you problems like this on a test or homework or something, you can assume that it is sort of on an integer value. I wanted that to be 4, negative 1, but now that I look at it, it looks more like 3.9. If I were to give you one in between, it would be pretty clear, like that point. That's 1.5 on the x-axis and only, let's say, half a step up. So 1.5 and 0.5. But this can get really tricky. How do I know it's not 1.4? You don't. You can only sort of estimate things. A point is supposed to be infinitely razor-sharp thin, so you should be able to zoom in on it, but this is good enough for now.